Hello, welcome to Arcserve Unified Data Protection Sizing, Scaling, Best Practice Review. My name is Gary Sussman, Principal Consultant here at Arcserve. Course description. In a technology world that grows more and more every day, the ability to plan for future growth and success becomes even more important. Because of this reason, the components of Arcserve Unified Data Protection are designed to keep up with the times. This course takes the challenge of today's IT environments to account by discussing not only hardware and software requirements for unified data protection, but how to scale the components of the solution that we have designed. You will also learn the best practice when deploying Arcserve Unified Data Protection and how to best plan to expand your deployments in the future. Sizing and best practice review topics will be covered. First, unified data protection archive elements and resources required. Next, the deployment breakdowns and how to size the recommended components. Finally, the Arcserve Unified Data Protection Linux unit sizing. We'll then talk about how to size the appropriate resources with some tools that we have available. And then concluding how to perform ongoing maintenance with the solution, how to scale and perform migrations. So that's what we're trying to accomplish with this course. But first, let's go over an introduction of who and what is Arcserve. Arcserve has been around for over 25 plus years. Today, we provide Arcserve backup and Arcserve Unified Data Protection as solutions for data protection. We provide Arcserve Unified Data Protection with software, and also we have available our appliances and cloud. Arcserve Unified Data Protection provides backups every 15 minutes. It provides reduced backups, reduced RPO because of our changed block tracking. We perform snapshots to provide data protection at the block level. We can then recover data at any time, recovering files, folders, bare metal recovery, also providing capabilities using hypervisor to perform virtual standby and instant VM. Arcserve UDP, again, provides backup recovery. We provide data protection to disk. We also can do copy to tape or archive to other resources like other disk, tapes, or cloud. We also can do, again, DR testing. Without backups, we can perform assured recovery. We also can do virtual standby. It was our proactive way of creating virtual machines. We also can do instant VM as well, where we don't have planned, but have access to our sessions. We can create VMs at any time. For those environments that need reduced RPO and RTO, we have high availability also. Arcserve RHA provides protection less than 15 minutes that our backups currently typically do. So any requirements less than 15 minutes, this is where RHA shines. So that's a high level discussion of our products today. What we're going to focus on is the UDP technology. UDP stands for, again, Unified Data Protection. It backs up not only your Windows, Linux, but also protects physical and virtual environments. We store these backups or recovery points on what we call our recovery point server, or RPS for short. There's no cost to deploying this RPS. Think of it as a repository or a backup server, if you will. You can have as many of these as you like in different locations, performing backup local to those resources. Once we have recovery point, recall we talked about we can spin up virtual machines from them. So either local or after replication, wherever the data is on the RPS, we can use a virtual infrastructure to provide disaster recovery. Virtual standby or instant VM are both features we can provide to spin up VM directly from the backup. The backups or RTO less than 15 minutes, this is where our RHA technology comes in. RHA does real-time replication and failover, where you have critical servers that maybe backup is just not quick enough, or this doesn't provide the data protection required. We can do RHA. Once we have backup, we can perform restores. whether it's Linux, Windows, or virtual machine data. We can restore them to the original or alternative resources. We can perform file level recovery. We can mount recovery points. We can do also bare metal recovery to dissimilar hardware. One another advantage of having a recovery point server is not only backup, but also replication. At no cost, you can provide replication between your recovery point servers. This way, you can avoid a single point of failure. These recovery points can go across the WAN efficiently because with replication, we do first synchronization between the recovery point servers. So it's optimizing data transfers. So again, this is a high level of the architecture of UDP. First, we have to protect systems, provide the destination. Once that, we can then do restores and other DR features like virtual standby, shared recovery, and replication. Typically, Arcserve Unified Data Protection, when we deploy the RPS, we have it local to your data. As you can see, my primary site, I have one where I'm protecting some systems. That way, if I need to do recovery local, it's fast and efficient. Also, we can do replication. The idea is, since we do change block tracking, we're only tracking and protecting unique data anyway. This goes for replication. When we synchronize the local to remote RPS, we'll only then send the block level changes. Again, we can have the RPS wherever you like data protection. Also, the idea is to avoid some point of failure, so we can replicate wherever there is an RPS, including in the cloud, whether it's public or private. Having an RPS will manage now recovery points at these remote sites, and it's advantageous to have the RPS because the deduplication that occurs is also considered as well. One other thing that we also can do with an RPS is archive data, whether it's to a local disk, network attached storage, or to tape. We can have areas where we can migrate our backups across your environment. This first part we'll now discuss is how to architect the elements, and let's also discuss the resources that are required to build the UDP architecture. First, let's discuss the architecture components. The first component of the UDP technology is the console. The console is what provides our web-based interface. It provides a 64-bit architecture for you to manage the whole entire solution. Once we have the console up, we can then deploy our second component, which is our agents. Typically, we provide agents on our virtual host or on physical servers. We then do agents protection for any VMs. So, for example, we'll deploy an agent on a Hyper-V host, but we can provide agentless backups of all the VMs, as well as workstations. We can deploy this agent. For VMware Hyper-V, we can do a single pass virtual protection of all the virtual disks without having agent inside any VM. This again can be all centrally managed, deployed with the web-based interface. The third and last component of this architecture is the RPS, or the recovery point server. Again, this is a Windows server that performs as the backup destination. This is where we qualify our data store. This is the server that performs all our inline data protection. It does our source side global dedupe, so we're only backing up the unique data from a backup approach. As with backup, it also can perform replication. It's built into the product at no cost. We also can provide encryption, and we can see data off and out, migrate resources off and to other recovery point servers. We call this Jumpstart. So RPS will provide a lot of capabilities. It performs the backups, the replication. It can act as a proxy to do your virtual standby, also archive to tape or other disk resources. Let's now discuss each resource individually. First up, the Arcserve Unified Data Protection Console. Again, the console is a web-based interface for this whole solution management. Console provides a web-based interface with a SQL backend. Deployed is a SQL Express by default, or you could use another SQL Server standard. Typically, there's resources required like a Tomcat Apache service, other components, engines, and services. So, total about 1 gig is typically recommended for every aspect. Console can be deployed on the Windows Server. We support all the way back to 2018 R2. I'm sorry, 28 R2. We also support 2016 recently. You can have as many console, deploy as many as you like. There's no cost to deploying the console. For example, I have one on the left for maybe an environment that needs to be isolated from the environment on the right. Both consoles you can access via web interface, and they both can manage each independently. You can also add consoles to each other for replication purposes. Another great feature of our console is role-based management. You can define users that have access to the interface using Windows authentication. Once they're in, you can also qualify what roles they'll have access to. There's different roles you can create or use the four default as you can see here. The idea is to define who and what users have access to with this technology. Another component is a gateway component. As I mentioned, the console, as you see in the upper left, can be utilized to manage an environment, but it requires additional resources like a SQL database. You may have lack resources in other sites, so we can deploy gateways as a way of managing these other sites that have non-point-to-point connection. So if you have remote sites with no VPN, totally isolated, instead of managing another console, we can deploy a gateway option instead. This gateway will allow you to basically centralize and see all the communications from one interface. Provide central management of all your sites so you can easily manage the solution in one single console. Another great advantage of the console is the 64-bit. Typically requires about 8 gigs of RAM. Again, the SQL Express is installed by default. Typically, 10 gigs of space is required with the database in mind. Speaking of the database, SQL Express is installed. Typically, that can maintain about 1,000 nodes. Uh, Typically, for 3 hours of scheduled backups, it can store about historically 30 days of logs and information. So there is a limitation of this SQL database. So if you perform higher frequent number backups or have larger nodes to manage, then you must consider using a standard SQL deployment. The max database size for SQL Express is 10 gigabytes. So definitely keep in mind the frequency of the backups you're occurring. You may outgrow the SQL Express database quicker than you would anticipate. So uh, keep in mind how frequently you do your backup and what number of nodes, how many nodes you're trying to back up as well. If you're deploying a full database, you have more advantages, of course. The full standard SQL database, we can support more nodes, 2,500 nodes. You can do much more retention, as you can see, 12 months easy, and the much larger database size, as you can see, because of that, 218. So that's console. A great way to access the solution, manage everything. That's an important component. You can install the console wherever you like, or the gateway in these remote locations to centralize management. Next component is the recovery point server. The RPS is our backup server. This is where we perform our backups to. It does our inline process. So all the operations, merges, catalogs, everything is done on the RPS. It offloads these tasks from your local resources. Also, it performs our block level, change block tracking, performs our, snapshots. So it acknowledges what blocks have been seen It only will back up the unique blocks because it has a hash database. So it checks every block. If there is a block found in our database, then we know, oh, let's index it. But we will further reduce then the backup time and then reduce the size of the backup because of that. Lastly, the RPS provides replication. So the idea of avoiding single point of failure, we can provide synchronization between RPSs and replicate just those change blocks. So we can eliminate single point of failure by replicating the data between these objects. So once again, when we do backup, all we care about is what blocks have changed. We can go down to a 4K block incremental. So even the first full, if we find similar 4K blocks, then even that uh, source dedupe, we don't need to back it up. The idea is this database is going to keep track of every block that it sees once we split it. If we search and there's a duplicate, a hash, then we don't need to back it up. But if it is unique, that's when we write to disk. If it's not, if it is unique, that's when we spend our time investment. But most likely, dedupe will again. The idea is to save our backup time and utilize less disk. And so this is how our inline process works. But we also do this globally. So after the first node is done, if any additional nodes for backup has similar blocks, again, we're going to optimize that data transfer. The product also does incremental forever. There's no need to do full backups every week anymore. The product maintains a synthetic full and otherwise. We also have an automatic merge process within the product that you also can schedule. So if I only want 3 hours kept, the fourth hour will automatically merge the oldest into the parent full. So at all times, we have what you want for retention depending on either daily, weekly, monthly, or custom. So we can therefore rebuild the blocks back to any point we want because we have the full that we have originally. So block level, incremental forever is how this technology works, all inline done on the recovery point server. Merges, scheduling, throttling are all also provided, again, to create the best type of environment that we need. Block incremental provides, again, just change block tracking, no more fulls multiple times. In addition to that, our source side and deduplication, you'll get a lot of tremendous savings on resources with this solution. We also provide encryption with our RPS, so anything in ingesting or being transferred in line or during transfer or at rest, whatever the case may be, we can protect that investment with 256 AES encryption. As I mentioned, the Arcserve RPS could be in Windows servers. It needs disk being a backup resource. You can have direct attached disk. You can have network attached disk, SAN attached disk. It really all depends on the resources that you're trying to protect. For example, we can back up using a file share. So if you have already an existing, hardware device, no worries. Our Arcserve RPS can offload and still provide backups to those other hardware devices using a file share protocol. You can therefore use those devices deduplication and their own compression. Otherwise, if it's just a bunch of disks, we can create our own deduplication store utilizing direct attach, SAN, depending on the environment. We'll further discuss sizing with other courses. Also with the RPS, when we create these data stores, we require 4 folders. The backup destination, this is where we restore if we need data. And then the 3 others are used for our dedupe. The unique dedupe data is kept in the dedupe data store. The hash is again our database that we reference if we're trying to find a unique block of data. And the index is again the occurrence of the files we've seen just once. So that does it for the RPS introduction to this course. Again, the unified data protection solution. There's a lot of projects. There's a lot of different ways we can deploy the solution. The different components that we've talked about as well. We'll go in further details in next courses. So stay tuned for other parts of this series. Thank you for your time on this first part of sizing, scaling best practice, reviewing the architectural components, and what resources are required. Thank you.